Hello everyone, in this video we'll be talking about two water soluble vitamins. They are pantothenic acid and pyridoxine. Pantothenic acid has B5 and pyridoxine has a B6. So first we'll discuss about B5, pantothenic acid. So pantothenic acid, to discuss its structure, it's a combination of pantoic acid and alanine. So alanine is an amino acid. So when you add alanine to pantoic acid, it will be converted to pantothenic acid. So here mainly it exists as beta alanine. So what is the main role of this pantothenic acid? It is acting as a coenzyme A. Coenzyme A. So wherever there is addition of coenzyme A to the reactions, there you require pantothenic acid. So here pantothenic acid acting as a donor of coenzyme A. So the coenzyme form of pantothenic acid is a coenzyme A, CoA. So when you write, so you have to write like this, CoA-SH. So this is the active form of pantothenic acid, CoA-SH. And coming to the sources, egg, liver, meat, yeast, milk, cereals, these are the rich sources of pantothenic acid. And RDA, how much amount of pantothenic acid you are supposed to take in the diet per day is 5 to 10 milligrams per day. And absorption transport, being water soluble vitamin, absorption transport is like simple, by simple diffusion. So active forms, coenzyme A and acyl carrier protein. So as I mentioned earlier, CoA-SH, this is one active form, the other one is acyl carrier protein, that means carrying acyl group, the protein which is carrying acyl group. So where this coenzyme A involved? So you see here, so beta mercaptoethanolamine. So mercapto means which is carrying sulfur group. Okay, so that's why you are writing CoA-SH. Okay, so this SH will be the functional activity, so which is having functional activity, and the pantothenic acid which is attached to the amino acid, that means alanine, which is serving to beta mercaptoethanolamine, alanine. Okay, and which will be attached to adenine. Okay, adenine, and what to say, it will be attached with the ribose phosphate, ADP. Okay, adenine ribose phosphate. So where and all this require? Coenzyme A. So one of the multi-enzyme complex in conversion of pyruvate to acetyl CoA. So the donor of CoA is this pantothenic acid coenzyme A, CoA-SH. Okay, PDH, alpha ketoglutarate dehydrogenase. These two reactions are the major one where involved in involvement of coenzyme A. So T-cell cycle in fatty acid synthesis also required, in cholesterol synthesis also required, and acyl carrier protein involved in fatty acid synthesis. Okay, these are the main contributions of pantothenic acid towards the carbohydrate and lipid metabolism. So deficiency, so pantothenic acid is like present in almost all the plant sources. Okay, so the deficiency is rare in humans, but still its deficiency causes burning fruit syndrome. And in experimental animals, it causes anemia, dermatitis and fatty liver. So the next one is B6 pyridoxine. So there are three types of pyridoxine. I mean, there are three forms, okay, of pyridoxine. Okay, that is B6, pyridoxine, pyridoxal, pyridoxalamine. Pyridoxine, pyridoxal, that means aldehyde, carbohydrate, I mean like aldehyde form is there, and pyridoxalamine, amino group attached to it. So you see the difference here, CH2OH is the aldehyde form, pyridoxine is the alcohol form. Here pyridoxal aldehyde form, pyridoxine is alcohol form, pyridoxalamine is an amine form where amino group attached. So the coming to talk about the sources, whole grains, legumes, liver, meat, yeast, vegetables, fruits. So these are all the rich sources of pyridoxine. Daily requirement or RDA. You are supposed to take 2 to 2.5 milligrams of pyridoxine per day. So the main speciality of B6 I'll tell you here. So far we have discussed B1, B2, B3 and B5. So all these are involved in energy production. That means energy releasing vitamins. But the main speciality of B6 is it is useful in protein metabolism. So for protein metabolism you require B6. Almost all the major reactions in protein metabolism require the active form or coenzyme form of B6, that is PLP, pyridoxal phosphate. Okay, and absorption transport is simple, okay, as being it is a simple water soluble vitamin. So in tissues, pyridoxine is converted to pyridoxal and pyridoxamine. That means alcohol form converted to aldehyde form and also amine form. So the active form, as I mentioned earlier, it is PLP. So popularly it is known as PLP. Okay, and TPP belongs to B1, thymine. So PLP is nothing but pyridoxal phosphate. Pyridoxal phosphate. You see here aldehyde form is there. So what are the functions? So as I mentioned, PLP is mainly involved in protein metabolism. Apart from protein metabolism, it involved in heme synthesis and also in glycogenolysis, the breakdown of glycogen that is stored in muscles and in liver. Okay, so for this we require pyridoxine. So the reactions where PLP required, transamination reactions, that means transfer of amino group from one amino acid to other keto acid to form new amino acid and new keto acid. So ALT, AST, alanine transaminase and aspartate transaminase, these are the classical examples for transamination. And deamination, removal of amino group from glutamic acid and glutamine, which is taking place in liver. So what to say, deaminases, the enzymes which are present in liver. Decarboxylation, removal of carboxylic group. Heme synthesis, where alanine and glycine involved in production of ALA synthase, there it require PLP. And production of niacin, that means synthesis of niacin from amino acid tryptophan, there also required PLP. Glycogenolysis, where when you require energy, the stored amount of glycogen has to degrade it to produce glucose for energy production, there you require PLP. So reactions you see here, transamination, deamination, decarboxylation, condensation, glycine and succinyl-CoA. Previously I mentioned about alanine, it's not alanine. Glycine plus succinyl-CoA involved to production of aminolevulinic acid, or you can say ALA. Okay, there you require ALA synthase enzyme. For that ALA synthase you require PLP. Without this there is no forwardness of the heme synthesis. So there is no synthesis of heme. So RBC will be incomplete without heme production or hemoglobin. And to talk about deficiency, it is also rare, as the almost all sources are available in the nature of rich of pyridoxine. So if in case the deficiency in humans, it includes microcytic hypochromic anemia, because heme synthesis required PLP. If PLP is not there, heme cannot be synthesized. So it leads to deficient RBCs. So deficient RBCs. So it leads to microcytic hypochromic anemia. Peripheral neuropathy. So peripheral neuropathy, why? Because tryptophan will be involved in production of niacin. So this production also hampered. So it causes peripheral neuropathy. Convulsions, also one of the characterization of B6 deficiency. So drugs like which are inhibiting the pyridoxine activity. So the drugs like anti-tuberculosis drugs, okay, isoniazid or isotonic or acid hydrazine, penicillamine, oral contraceptives and excessive alcohol consumption are the factors which prevent the pyridoxine absorption from the intestine. So daily requirements, 15 to 20 milligrams per day you will be requiring. So that's all about B5 and B6. Thanks for the listening. Thank you.